All right, we're going to talk about vectors here for a few minutes. A vector, remember, is anything that has a magnitude and a direction. So let's say I have here vector A. And I have vector B in some other direction. Let's say it's going like this. Vector B at some distance. Changes so they're not the same length. All right, those vector quantities, and usually you're supposed to put a vector symbol over them. I got to admit right now I'm sloppy about that, so lots of times I'll have vectors, but I will get lazy and not put them on there. I expect you to just be able to know if we're dealing with vectors that that's a vector. So if I write A, it's a vector. I will try to keep track of it, but it's easy for me to forget those things. Now, what I want to figure out is I want to be able to add vectors together. So what I want to do is say, well, what do I get if I have vector A plus vector B? Essentially, I'm going to get a new vector we call vector C. How do you do that? Well, a vector, remember, has a magnitude, which is the length, and a direction. But I can move it around anywhere I want on the board, anywhere on your paper. You can move that vector as long as you never change the magnitude and the direction. So I'm going to go over here. I'm starting with vector A, so I'm just going to redraw vector A so that it is going the same direction, so it's got to be parallel to that one, and the same length. But when you add vectors, you take the next vector here, and you take the tail of this vector, so this is the head, this is the tail. You take the tail of this vector so it lines up with the head of this one. So I'm just going to move this vector over to here, so that's going the same direction, same length. Those two should be exactly parallel, same length. That's vector B. Notice all I did was move it so that its tail matches the head of vector A. When I do that, I get vector C by starting at the tail of the first vector and going to the head of the last vector. So this is vector C right here. Now the question is would you get the same thing if you added it this way? If I said vector B plus vector A, does that equal vector C? I mean, if I flip them around, am I going to get the same thing? Well, this is what's called graphically adding vectors. We're going to do the same thing. So now I'm going to start with vector B. So I'm going to put my vector B. Remember, I can put it anywhere. Here's my vector B. And then I take vector A, right here. But I'm going to put the tail of it to the head of vector B. So vector A is going to go like this. So those are parallel. Vector A, vector B. And whereas vector C, it goes from the tail of the first one to the head of the last one. Here's vector C. The answer is vector C is exactly the same. So yes, vector addition is what we call commutative. You can do it either A plus B or B plus A. You're going to get the same value. Can we subtract vectors? Yes. So what if we do vector A minus vector B to get vector D? All right. Vector A minus vector B. Well, we're going to do the same thing. We're going to start with vector A. So here's vector A. Same as it always was. Keep it the same length. What's it mean to be minus? Minus just means it's exactly the opposite direction. So the sign is just telling you direction. So when I say minus B, notice how B is going this way. Negative B would be the same one flipped around, meaning it's just going to put the head down here and the tail up here. So I'm going to add, this is just like adding negative B. But negative B is just B flipped around, so B is going to be the same, except it's going to go this direction. Notice I'm forgetting vector signs already. And then D, vector D, again, is from the tail of vector A to the head of vector B, or from the tail of the first to the head of the last one. So all you do when you have subtract is you flip the sign of the vector. However, if we do vector B minus vector A, are we going to get the same answer as A minus B? Well, let's do the same thing. Now we're starting with vector b, but we're starting with positive b, so remember we have to go back to our original, so it's this way. So we have vector b going like this. All right, vector b going like this. Same as this one right here. Now we have to subtract a, so we have to add a negative a. So we flip a around, we put the head over here, tail over here, and we add it to vector b. So vector a now goes like this. Same as this one, it's just flipped the other way. And then what is vector e? Vector e is going like this. Okay. So, what's the difference between D and E? They're the exact same length, they're just going the opposite way. D is going this way, E is going this way. Same thing if you want to think about it, just arithmetic. If I do 4 minus 2, I get positive 2. But if I do 2 minus 4, I get negative 2. So all I've done is flip the sign. And in case flipping the sign for vectors means flipping the direction. Now, you can also go back up to here, do this talking about adding vectors. I can go a plus b is equal to c, or b plus a is equal to c. So technically, I can do the whole thing as a parallelogram. So I could put vector a here and vector b here. B, this is a. So when you're adding vectors, they can sometimes call it the parallelogram method. Essentially, you make a parallelogram and it's the diagonal of the parallelogram when you add them together. All right. So basically, when you're adding vectors, just remember to, I always start with the first vector, take the next one, add the tail of it to the head of the next one. What if I have vectors that are in a line? So I have vector A like this, and vector B like this. So they're both going the same direction. Well, then that even makes it easier, because then you do A plus B is equal to C, and when you draw it, it's just going to be A, and then you take B and you add it to the end. This is A, and you're going to get C is equal to the total distance. But I can rearrange this just like I can rearrange an arithmetic equation. I can move this to this side and say, oh, A must then be equal to C minus B. And if I was going to do that, how would I do that graphically? Well, here, I'm going to do this side over here. I'm going to C, this is C, minus B means I'm just going to add B in the opposite direction. So I'm starting at the head here, I go B here. And what do I get? Well, I go from the tail of the first to the head of the last, I get vector A right here. Notice those match. So yes, you can rearrange vectors in vector arithmetic just like you would do any other equation. All right. So that is a simple part of what we call graphical vector addition. Chapter 3 we'll get into more arithmetic or trigonometry for adding vectors.